Hi students, and welcome to today's lesson. I'm Mrs. Baidani. Today we will explore the question, how do we describe our view of the sun, the moon, and stars in Earth's sky? Are you ready? Grab your pencil and your science journal, and let's get started. Imagine you are searching for buried treasure on an island far out at sea. You have this treasure map, and you already made your way to the place where X marks the spot. You're ready to start digging for treasure. But wait, your friend has both the shovels. She's still at the ship and doesn't have a map. You need to call your friend and give her clear directions over the phone. What will you say to guide your friend to the treasure? How will you tell your friend how to get from the docked ship to the X that marks the treasure chest? Let me show you the path and how to get to the X. How would you get there? What directions will you give? You might say something like, go past the statue toward the temple. When you get to the giant palm tree, turn left and then right to go around the back of the temple. Keep going. You'll see a huge cave on your left and a lake on your right. When you get to the creek, cross the bridge and turn right. Follow along the creek until it bends away, then take 10 steps towards the palm trees at the eastern coast of the island. There you'll find a giant X that marks where the treasure is buried. Those are great directions. When you give a friend directions, you're helping them navigate. Navigation is the process of following directions to get from one place to another. Maybe you've used a GPS to help you with navigation. What characteristics did our directions have? We use direction terms such as left and right. We use distances too, right? We told our friend how many steps to take. We also use features on the island in our directions. We can use features on the island as landmarks to guide our directions. A landmark is an object or feature in an environment that is easily seen and can serve as a guide. What landmarks did we use in our directions to the buried treasure? We said, go past the statue, right? So the statue is a landmark. We also mentioned the temple, the cave, the creek, and the lake in our directions. Those are all landmarks. Great work! But how would we navigate if we couldn't see any landmarks? Imagine you are out at sea with no land in sight and without tools such as a map, GPS, or a compass to help you find your way. How would you know which way to go? What can humans use to help them navigate at sea during day or night? Do you think we could look for landmarks in the sky? That's a great idea. Maybe we could use the sun, the moon, and the stars to navigate. If we look more closely at the sky to identify patterns, that might help us answer the question, how do we describe our view of the sun, the moon, and stars in Earth's sky? Let's see whether we can use these strategies to find our way around Polynesia. Look at this map. This shaded part of the Pacific Ocean is called the Polynesian Triangle. This area measures more than 10 million square miles. That's 3 times larger than the continental United States. Wow! What would it be like to navigate in this vast ocean? What do you notice about the land and water in this part of the world? I see mostly ocean and not much land. Do you notice that too? What else do you notice? Let's zoom in. I wonder whether those bumps are small islands. I can't tell. Let's look at the other map again. What do you notice when I zoom in? I notice many small islands placed far apart and surrounded by water. Even though these islands are so far apart, the Polynesian people who live on the islands today share a common language and culture. Their ancestors arrived on the many small islands in this vast area of ocean between 800 BCE and 1300 CE. Wow! So some of their ancestors arrived almost 3,000 years ago. But how did people navigate between islands back then? Let's look at another map. This is the island of Rurutu, and this is the island of Tahiti. What do you think the journey from Tahiti to Rurutu would be like? That is a really long way to travel in the open ocean. How would you navigate the 300-mile trip without landmarks or modern tools for navigation? How did the Polynesians find their way from island to island? Well, let's read the article, Polynesia's Genius Navigators, by Liesl Clark to find out. While we're reading the article, let's see what evidence we can find about how Polynesians navigated these great distances. How did the first inhabitants of Easter Island arrive? It is the most remote inhabited island on Earth. The coast of Chile lies 2,300 miles to the east, Tahiti 2,500 miles to the northwest, and the nearest island with a total population of 54 people is tiny Pitcairn, 1,400 miles to the west. The answer lies in the deeply rooted traditions of Polynesian culture. The people of the Pacific are intimately tied to the ocean. They sailed the sea hundreds of years before Europeans, using voyaging canoes crafted from island materials and stone tools. The Polynesians approached the open ocean with respect. Indeed, the ocean was integrated naturally into Polynesian culture, as they came from small islands surrounded by vast ocean expanses. In island culture, the double canoe and its navigator were integral to the survival of the people. As an island became overpopulated, navigators were sent out to sail uncharted seas to find undiscovered islands. Thousands of miles were traversed without the aid of sextants, a type of navigation instrument, or compasses. The ancient Polynesians navigated their canoes by the stars and other signs that came from the ocean and sky. Navigation was a precise science, a learned art that was passed on verbally from one navigator to another for countless generations. In 1768, as he sailed from Tahiti, Captain Cook had an additional passenger on board his ship, a Tahitian navigator named Tapaya. Tapaya guided Cook 300 miles south to Rurutu, a small Polynesian island, proving he could navigate from his homeland to a distant island. Cook was amazed to find that Tapaya could always point in the exact direction in which Tahiti lay, without the use of the ship's charts. Unlike later visitors to the South Pacific, Cook understood that Polynesian navigators could guide canoes across the Pacific over great distances. As we read the article, what evidence did we find that Polynesians navigated great distances in the ocean? They did not use tools such as a compass to navigate. They used the stars and other signs from the ocean and sky. And they passed their knowledge verbally from one generation to the next. So, the ancient Polynesians used stars and other celestial objects to find their way. Celestial is the word ancient cultures created to describe objects in the sky. Using celestial objects such as stars, the sun, and the moon to find one's way is called celestial navigation. Do you think that people still use celestial navigation today? Actually, they do. People studying to become sailors and pilots at the United States Naval Academy continue to learn how to navigate by using celestial bodies even today. But how do you think humans can use celestial objects for navigation? Well, I remember that sun rises in the east, so that could help figure out which way is east. And if the celestial objects stay in the same place, we could use them like landmarks to help us find our way. What must be true about celestial objects if they can be used for navigation? Well, they must be visible in the sky, right? And what if they are moving? There must be some sort of patterns in their movement so that we can predict where they will appear in the sky. There must be some consistency in the location and movement of celestial objects for humans to use them as landmarks in navigation. Let's look at the sky for 3 days to see whether we can find any patterns. These photographs of the sky were taken at the same place at the same time for 3 days in a row. What objects do you observe in the sky? Do you notice the sun in each of the photographs? If so, well done. What else do you notice? I see different types and amounts of clouds. How interesting. What patterns do you notice about objects in the sky? One of your tasks after today's lesson will be to answer this question. Can you predict what you will see in the sky on the next day at the same time? Another one of your tasks after today's lesson will be to predict where the sun will be the next day. Wow, we learned so much about celestial navigation and early Polynesian navigation today. Can you imagine sailing on a ship through the vast Pacific Ocean without modern tools for navigation? That would be an adventure. Remember when we gave your friend directions to the buried treasure? How are celestial objects similar to the landmarks in our directions? How are they different? Well, you couldn't tell your friend to turn right at the sun, could you? The sun is too far away. But if you know where the sun will be in the sky at a certain time of day, maybe you can say, walk toward the sun. I still have a lot of questions about how ancient Polynesians, such as Tupaya, use celestial objects to navigate. Do you? In the next lesson, we'll continue to explore by drawing a model of celestial navigation together. See you next time for more adventures in navigating.
And welcome to today's lesson. I'm Mrs. Davis. Today, we will explore the question, how do we describe the view of the sun, the moon, and stars in Earth's sky? Are you ready? Grab your pencil and your science journal and let's get started. Imagine that you're sailing across the Pacific Ocean with legendary Polynesian navigator Tupaya. You're traveling from one small island to another small island that is 300 miles away. How can you get there? The sun sets and you look up at the night sky. You see a moon and many stars. Tupaya turns your boat slightly to the right. How does he know which way to go? Then you notice that Tupaya is also looking up at the sky. The stars and moon help him know where to steer. In our last lesson, we read about navigators such as Tupaya who use celestial objects to navigate on the open ocean. We realized that humans can use celestial objects as landmarks to help them get from one place to another. But we're still not sure exactly how the navigation works, are we? We think that if celestial objects such as the sun, moon, and stars move, then they must move in patterns. If we can figure out what those patterns are, we can predict where objects will appear in the sky. To help us identify patterns, we observed the sky just like Tupaya did. We looked at photographs of the sky taken at the same place at the same time for 3 days in a row. What patterns did you notice about objects in the sky? Maybe you noticed that the sun appeared to be in the same position in the sky at the same time each day. This is a great observation. But what about the other objects in the sky? Did the clouds appear in the same position in the sky at the same time each day? No, the clouds are different in each photograph, right? I noticed that on April 27th, the sky had almost no clouds, but on April 28th, the sky was almost covered in clouds. And on the 29th, the sky has just a few wispy clouds here and there. So, the amounts and positions of the clouds in the sky are different each day. How interesting. What else do you notice? What stayed the same? Based on our observations, can we predict what we will see in the sky on the next day at the same time? Did you predict that on the next day at the same time, the sun will appear in the same position as it did on the 3 previous days? If so, great job. What other landmarks or objects did you include in your prediction? Maybe you included the fence and trees, since those objects remained in the same position each day. Nice work. You may have included clouds in your drawing, but we can't predict where the clouds will be, right? The location of the clouds does not seem to follow a pattern. So, the sun was in the same place in the sky at the same time each day that we observed it. Its location was predictable. But how can people use the sun or other celestial objects to navigate? Well, imagine you're sailing on the ocean. You know that the sun is in the same place every evening. So, you can use this knowledge to figure out where you are and to keep the boat moving in the right direction. What additional information would you need to use observations of the sky for navigation? Were you thinking we would need to know if the sun or other celestial objects move across the sky? I was thinking that too. We would have to navigate differently if celestial objects move across the sky than we would if they stayed in the same place. And if they do move, we would need to know which direction they move in. We would have to navigate differently if celestial objects moved across the sky. We would also want to collect data on the position of the sun or other celestial objects for more than 3 days to see if the pattern changes. In fact, humans have been observing the sky for thousands of years. Throughout history, many cultures have learned a lot from observing the sky. Ancient people from Polynesia shared their knowledge of celestial objects by talking to each other. However, many other civilizations created visual ways to show the patterns they observed in the sky. We can use our observations and predictions of the location of the sun to draw a model of how ancient Polynesians could have used celestial objects for navigation during the daytime and nighttime. In this navigation model, we will want to include any patterns we observed while looking at the sky. Where should we start? Let's split our model in half and make one side daytime and the other side nighttime. Make sure you include these labels in your model. We are navigating in the ocean, so we can include ocean water. And since ancient Polynesian navigators were sailing from island to island, let's include an island in our model as a landmark. Then we will be able to see where the celestial objects are in relation to the island. We will also need to include celestial objects. Which celestial objects should go on the daytime side and which celestial objects should go on the nighttime side? To answer this, pretend you're a navigator looking up at the sky. What would you see in the sky during the day? What would you see in the sky at night? What else should we include? One of your tasks at the end of this lesson will be to draw your own navigation model. What objects and patterns will you include in your model? Wow, we learned so much about celestial navigation and early Polynesian navigation. The ancient Polynesians noticed a lot of patterns about the position of celestial objects in the sky, and we observed some patterns together too. What patterns do you notice in the appearance of the sun, the moon, and the stars in the sky? One of your tasks at the end of this lesson will be to answer this question. Imagine once more that you're on a raft at night in the middle of the Pacific Ocean. You look up and you see a clear sky with thousands of stars. You wonder, would the stars look the same if you were sailing in the Atlantic or on the other side of the world? And what if you were looking at the stars from somewhere altogether different? What would you see if you were floating high above the earth in the sky itself? In our next lesson, we'll learn about some people who got to see a very different view of the stars as we continue to explore the question, how do we describe our view of the sun, the moon, and stars in Earth's sky? Let's review your tasks for today. First, draw the navigation model. Second, answer the question about patterns in the appearance of celestial objects.